In this class we will see the motion of an inclined plane, motion of an object on an inclined plane. So let me get into the discussion. So I am going to draw a plane here. Let this be a plane. Let the plane be PQRS. I am drawing a 3D image of it. So this is a plane where the surface of this one part of the plane is PQRS. Now I am going to take a ball and I am going to make it roll over the plane. So this is a ball. Let this point be A, and I am making this ball to roll in a straight line with parallel to the sides. So let this be AB, and I am drawing the inner dimensions of it. Let this point be C. So what I am going to do is I am going to take a ball here and I am taking a point A, B, and let's take ABC, or the plane is making an angle theta with the horizontal. So this is the condition I am going to take for explaining the motion of an object in an inclined plane. So let's take this particular section. I am going to take this particular section. Let this be A, C, B, and it is making an angle theta. Now what I am going to do, let the height of the plane or be h, let this be h, you can see even AC is h. This ball is going to roll over the plane towards the point B. Now let's calculate the dimensions of the distance or the displacement covered by the ball from A to reach the point B. So to do that, let's take the Pythagoras theorem here. You can see this is 90 degrees, and what we get? We get sine theta is equal to AC by AB. Now what would be AB? AB is equal to AC cosecant theta. Now I am going to write AB is equal to H cosecant theta. Now we can see AB is equal to H cosecant theta because AC is H, the height of the plane, and is making an angle theta with the horizontal. Now this is one case we have, and while discussing this concept I am going to take three cases to explain this concept. So in case 1, what I am going to do is, this is case 1, and I am going to take case 2 and case 3. So I will be discussing three cases. I'll let you know what are the three cases. So initially I am taking that the ball will roll over the plane towards the point B. Now let's take a case. What happens if the ball just falls from A to C? That is, I am just dropping the ball vertically. So here what I am going to do is I am going to calculate two parameters, that is the time of flight and the velocity of the ball to reach to the point B or C, or to the lowest point. Now in the case 1, what I am going to do is the ball is going to take a path from A to C, that is, it just falls straight. So what would be the time of flight, or the time taken by the ball to move from A to C? As we know from the equations of motion, the formula S is equal to ut plus half at square. In this case you can clearly see what is S. S is the h. Now I am going to take S is equal to minus h because I am considering the motion to be in the downward direction. So as we have already discussed, whenever we move upwards it is taken as positive, whenever it is moving downwards it is taken as negative. So minus h is equal to, what is u? If I see the ball moving from A to C, I am just dropping the ball, I am not throwing the ball with a velocity u. So u is 0 into t. Now what is A? A, as you know, A is acting in the downward direction. Again in the downward direction, A is minus g. So it is minus half gt square. Now what would be the time of flight? You can clearly see minus s is equal to minus half gt square, and t becomes 2h by g. So this is the time of flight of the ball if it is just dropped in a vertical line. Now what would be the velocity? Let's take again one equation of motion. V square is minus u square is equal to 2as. Here again, what is the final velocity? We are going to calculate it. V square. What is u square? As I have already told you, I am just dropping the ball. That is, I am dropping with a velocity 0. And what is making the ball to come down? It is coming under the influence of gravity. So let's take, this is 0, so is equal to, what is A? Is minus 2, the HS is minus H. So finally you get V square is equal to 2GH, V is equal to root of 2GH. So we've calculated time of flight and velocity. So this is the equation that we got when the ball is falling in a vertical line. Now what would happen? The ball rolls over to the point B as the concept that we are discussing now. Now let's see how to see that. Now if I'm asked to calculate time of flight and the velocity with which the ball comes to the ground or point B from A is using by the same equations of motions, let's do that. So as we know, the path taken here is A to B. That is, the ball will come to the point or come downwards to the point B. So let's take the equations of motion. S is equal to ut plus half at square. Now what is the equation of motion here? When we apply the equation of motions to this case, as you can clearly see, what is the displacement? AB is the displacement. What did we get? AB is h cosecant theta. H cosecant theta is equal to, what is u? As I have already told you that I am not pushing the ball, I am just keeping the ball A, I am keeping the ball at point A so that it just rolls over under the influence of gravity. I am not pushing it. So the velocity at point A becomes 0 again. So this is 0 into t, 0. Then what happens? Minus, so here what is G? Now here comes the picture. What should I write? A. Should I take G? No, I cannot write G because, now let's take this particular part. Now let's take the ball is rolling at this point. Now how will the gravitational force act? It acts in the downward direction, G. Now what would be the component of G acting in the direction towards AB? Let's find out. Now before getting to that, I am going to segregate this into vertical and horizontal component to calculate the values. So I am just drawing it. Now this is one plane, I am just drawing an horizontal and vertical component. Let's see, this angle is theta. Now what would be this angle? This will be theta and this will be 90 minus theta and this will be theta. Now you can see the angle, this angle is theta. So what would happen? The gravitation in this side is G cos theta. And what would be the gravity in the line AB? It would be G sin theta. So you need to observe here, gravitation acts in the downward direction vertically, but as you can see here, since the ball is rolling over, I am more concerned about the effect of gravitation in the slope. And you can see, how did I calculate? I just divided into vertical, horizontal components. G is acting in this direction, it is making an angle 90 minus theta with the vertical, with the plane. So what happens? The component of G onto the vertical, onto the plane is G sin theta. So what would be the acceleration acting in the direction downwards, that is making the ball go downwards, that is G sin theta. So I write this as minus half. Why am I writing minus? Because as again I am telling, this is minus G sin theta because it is pulling down. Though the magnitude is G sin theta, but the value that we take is minus G sin theta. So it becomes minus G sin theta t square. So what happens? As you can see, minus h. Why am I writing minus h? Because again they are coming in the downward direction. So what happens? Minus minus gets cancelled. So you get h cosecant theta is equal to half G sin theta t square. So finally t square is equal to 2h by G cosecant square theta. T is equal to 2h by G cosecant theta. So this is the time required by the ball to come from point A to B when I am dropping it from point A. Now what would be the velocity? Let's calculate it. So the velocity is v square minus u square is equal to 2a. I am again taking the velocity, I am taking the equation of motion. So what is v square? V square is the velocity we are going to calculate. V square is equal to a is, as we already calculated, a is g sin theta. So what happens? Minus, so this is 2 minus g sin theta into minus h cosecant theta. Why am I writing minus? As I have told you, they are coming downwards because the displacement is in the negative direction. So you can see g. So what you can see, sin theta into cosecant theta is 1. So what is the final value? V is equal to 2 root 2 gh. So you can clearly see the velocity is the same while I am dropping the ball from A to C or while it is moving from A to B. Now let's take the case 3, that is very important. What would happen to the ball if I am making it to roll over in a line that is not in the straight line? Let's do that. I am taking a path here. Let this point be D. I am going to make the ball roll on over a path AD. Let's see what happens, and it is making an angle alpha. Now I am going, if I visualize this segment, if I visualize the segment from this side, let me draw what happens. It looks something like this. This is A, B, D, and you can see it is making 90 degrees. Since you can see these are parallelograms, this angle is 90 degrees. So what happens? Let's observe. From this side, if you observe, it looks like a rectangle, or you can say it is a parallelogram as such. It's a rectangle as it is. You can see they are making a 90 degrees. So this is 90 degrees. So in this triangle ADB, you can see what happens. This is alpha. Now let's apply the Pythagoras theorem and look what happens. As we have already calculated, AB is what? It is h cosecant theta. And what would be AD? How to calculate AD? You can see, let's take cos alpha is equal to AB by AD. What happens? Now AD is equal to AB secant alpha if it goes this side. So AD is equal to h cosecant theta into secant alpha. This is what we get. What is this? AD is the displacement of the ball if I make this ball to move from A to D. Now let's apply these conditions to the equations of motion in case 3. What happens? That I am going to calculate time of flight and velocity of the ball when it moves from A to D, and let's see what happens. So I am going to write this. So as we know, S is equal to ut plus half at square. Now what is S? In this case, the S is, it is moving A to D. So AD is what? H cosecant theta. Now if I see h when I say h cosecant theta, it is actually minus h cosecant theta secant alpha, because again it is going in the downward direction. So secant alpha is equal, u is what? 0, because I am dropping the ball, and I am dropping the ball in such a way that it moves in the direction A to D. Now then what we are left with? Yeah, we have half at square. Now what is the acceleration? It's very important to note that in this case we took the acceleration to be g sin theta, that is minus g sin theta. But in this case, what would be the acceleration? You can see when the ball is rolling from A to B, the acceleration is g sin theta. Now what would be the effect of, what component of this acceleration is responsible for the ball to move from A to B? That is, the ball takes the acceleration, g sin theta is responsible for the ball to move from A to B, and what component of g sin theta is making the ball to move from A to D? So this is the ball, when it moves from A to B, it is minus g sin theta, that is g sin theta. Magnitude is g sin theta, the direction is minus g sin theta. Now if the ball is moving from A to D, what component of the g sin theta is responsible? You can clearly see, if I take a component, the component of it is g sin theta cos alpha. If you take the component in this case, you can see I am taking the component. This is the component I am taking. What happens? If I am taking the component, this is alpha, this is g sin theta, let's take. I am taking the component here, it is g sin theta cos alpha. So I am taking the component along the direction AD. So what happens? Here it becomes minus half g sin theta cos alpha into t square. Why am I writing cos alpha? Because g sin theta's, this is g sin theta, the component of g sin theta onto the line AD is g sin theta cos alpha. You can see, you can refer my videos on the components of a vector to understand it. So let's see what happens. This gets cancelled, so it becomes h cosecant theta secant alpha. Secant alpha is equal to half g sin theta cos alpha t square. So what is t square? T square is equal to 2h by g cosecant square theta secant square alpha. So finally we get t is equal to root 2h by g cosecant theta secant alpha. Now this is something we have got. Now what would be the velocity here? The velocity would be, the velocity we can calculate using v square minus u square is equal to 2as. Here again what I am taking, v square is equal to, u square is 0 because I am dropping the ball, I am not pushing the ball. So what happens? 2 into a is what? It is minus g sin theta cos alpha. So minus g sin theta cos alpha into what is the displacement? Displacement is AD, the displacement of AD. So what is this? H into h cosecant theta secant alpha. Cos alpha into secant alpha is 1, sin theta into cosecant theta is 1. So finally we get v is equal to root 2gh. Now we have seen, we have got the velocity to be the same in all the cases, but the time of flight is varying. That is, time of flight means the time required for the ball to come from A to C is very low, and you can see as the slope increases, what happens? The time of flight increases, because cosecant theta value is, like when you take theta value is, theta is equal to 90 degrees, what happens? Theta is equal to 90 degrees, you get the lowest, the slope is maximum and the time of flight is minimum. As you keep on increasing the slope, in this case the slope is from A to B, and the third case its slope is from A to D. If you see the three cases, what happens? The time of flight is different but the velocity remains the same. So this is an important concept, and we shall discuss the next concept in the next video.